Okay, Bismillah ar-Rahman ar-Rahim. Summary for chapter 19, section 1. Okay, in this section we'll cover how to assign the oxidation number to reactant and the product species. We'll define oxidation and reduction, and we will relate it to the oxidation reduction reaction or redox reactions. First of all, the meaning of oxidation. Oxidation is a process through which an element or a molecule, before we start the oxidation state, we will talk generally about the oxidation numbers. They are assigned to an element in the molecule. In the molecule is based on the distribution of the electrons in the molecule. Okay, so according to the distribution of electrons inside the molecule or inside the element, so the element or the molecule will take certain oxidation number. The rules by which oxidation numbers are assigned are found here in this they are found here in this table. You will find this table in the textbook also in section 1, chapter 19. The first rule in assigning oxidation numbers, okay, that the oxidation number of any uncombined element is 0. If I'm talking about a pure element, like for example sodium element here, its oxidation number is 0. If I'm talking about oxygen element as diatomic element, also its oxidation number is 0. Chlorine molecule, also its oxidation number is 0. Iron, oxidation number 0. So any element found in its elementary form as monoatomic or diatomic, its total oxidation number is 0. The oxidation number of monoatomic ions equal to the charge of this ion. Like for example, Cl negative, its oxidation number is -1. So if I have neutral atom, the oxidation number will be 0. If I have an ion, so the oxidation number equal to the charge of this ion. Like for example, Na positive, so the oxidation number will be +1. Cl negative, it will be -1. Let's say aluminum ion, it will be +3, and so on. For more electronegative element in a binary compound is the compound that's made up of 2 atoms or 2 elements combined together. The oxidation number of the more electronegative element in this molecule is equal to the charge of its ion. It means if I have NO, for example, the oxidation number for the oxygen will be the oxidation number of the oxygen ion. An oxygen ion takes a -2 oxidation number, so the oxygen inside this binary molecule will be -2. Okay? So this is generally for binary molecules if we're talking about 2 different elements having different electronegativities. The oxidation number of fluorine, always -1. Why? Fluorine is the most electronegative element in the whole periodic table. That's why it takes an oxidation number of -1, always negative. Okay? Point number 5, oxygen has an oxidation number of -2. Always, oxygen has a -2 oxidation number, except in 2 cases. If it bonds with fluorine, as it is the highest in electronegativity, so in this case it will take +1 or +2 oxidation number. And also in peroxide, like in hydrogen peroxide, in this case it will take -1. So again, oxygen takes oxygen takes -2 oxidation number generally, except the 2 cases. The first case, if it combines with fluorine, in this case it takes +1 or +2. And in the second case, if it bonds in a peroxide molecule, like what? Like hydrogen peroxide, H2O2. The oxidation number for the oxygen here is -1, not -2 like in the normal conditions. What about hydrogen? Hydrogen oxidation state is always +1, except when it bonds with metals. With a metal, it takes a -1 oxidation number, like lithium hydride here, LiH. So the H or the hydrogen takes -1 oxidation number because it bonds with a metal. But in case of water, H2O, no. The hydrogen takes a +1 oxidation number because it bonds with another nonmetal, especially if this nonmetal has a higher electronegativity. In compound, the elements of groups 1 and 2 as well as aluminum, they take the oxidation number of their group. بمعنى if group 1, any element of group 1 takes an oxidation number of positive 1, group 2 positive 2, group 13 like aluminum takes oxidation number of positive 13. But what about the transition metals? Transition metals, they vary in their oxidation numbers from positive 1, positive 2, positive 3. So we can calculate it generally during answering. Point 8, the sum of oxidation numbers of all atoms in a neutral compound is 0. Let's calculate it for calcium carbonate, CaCO3. The oxidation numbers for all of the atoms here is 0 because it is a neutral compound. Let's calculate it for carbon, for example. طبعا calcium, we know it's a member of group 2, so it takes a positive 2 oxidation number. Oxygen, normal state for oxygen. Okay, the point number 5 is negative 2. Okay, so we can calculate it easily. Negative 2 by 3 equal negative 6, and then positive 2 for calcium, okay, equal 0. So the X here for the carbon will be, the X here for carbon will be positive, it will be positive 4. Okay, so carbon takes positive 4. Positive 4, positive 2, positive 6, negative 6, total of 0. Okay, so you can apply the same concept for any neutral compound. The last point, the sum of the oxidation numbers for polyatomic ions. If I have group of atoms having a charge, so in this case the total of all will be equal to the charge of this molecule, like carbonate CO3 negative 2. This is a polyatomic ion. So the total or the sum of all the oxidation numbers here will be equal to the charge of this molecule, which is negative 2. But here the total of all equals 0 because I'm dealing with a neutral compound. Here I'm dealing with a charged particle. Okay, so let's calculate. For the oxygen it will be negative 6. Okay, I want to get it calculated for carbon, and this is negative 2, so it will be of course positive 4. So the oxidation number for the carbon here will be positive 4, negative 6 equal negative 2. So by this way I'm done with the assigning the oxidation numbers for different elements, okay, in different conditions. Let's apply. Assigning oxidation number for nitric acid, HNO3. It is a compound, so the sum of all will be 0. Okay, using our rules, hydrogen in normal conditions take positive 1 oxidation number, and oxygen takes negative 2 by 3 equal negative 6. This one positive 1, negative 2. Okay, so we need to calculate it for the nitrogen, X. All of this equals 0. So simply nitrogen will take what? It will take positive 5, because positive 5, positive 1 equal positive 6, negative 6, total of 0. And this is clear here that the oxidation number of the nitrogen is positive 5. Okay, now let's learn what's meant by oxidation. Oxidation is a process through which atoms or ions of an element experience an increase in the oxidation state. So once you see an increase in the oxidation state, so you can judge that I have oxidation. And the species or the element or whatever element, element ion or polyatomic ion whose oxidation numbers increased are called oxidized, or we represent them or we call them oxidized elements. Okay, for example, sodium. As it loses an electron, it changes to a positive ion and the electron is out, right? So the oxidation number for oxygen as an element is 0, as an ion is positive 1. So what happens in the oxidation number? Increase in the oxidation number. So I judge that, or I determine that this process includes oxidation because the species here, okay, suffers an increase in oxidation number, and now we can say that sodium is oxidized. Okay, the opposite for reduction. Reduction is any process that involves any decrease in the oxidation state, any decrease in the oxidation number or oxidation state. And the species, we call it reduced, or we represent it by the word reduced, like chlorine, oxidation number 0. It gains 2 electrons during a reaction to form 2 chloride ions. What is the oxidation number here? 0. What is the oxidation number here? It is -1. So it suffers decrease in oxidation state. So we can represent it. This reaction represents a reduction reaction or a reduction half reaction, and the chlorine here is reduced. Okay, now, what are oxidation reduction reactions? Oxidation reduction reactions are reactions that involve both oxidation and reduction processes. So any chemical process in which elements undergo changes in their oxidation numbers, okay, so in this case we represent it as an oxidation reduction reaction, okay? So we can represent it by a redox reaction. So redox is abbreviation for the oxidation reduction reaction. If I'm talking about the part of the redox reaction involves oxidation only or reduction only, so I'm representing half reaction. So back to our half reactions. Here, I consider this step oxidation half reaction. And I consider this step reduction half reaction. Together they make up the redox reaction. Okay, so here is the redox reaction composed of 2 half reactions. Okay, 2 half reactions, one of them represents oxidation and the other one represents reduction. Okay, now let's take an example for oxidation reduction reaction. Copper here suffers oxidation because we can see that it suffers an increase in the oxidation number from 0 to +2. Okay? Sodium here suffers reduction because it changes from +5 to +4 oxidation number. So it suffers decrease in the oxidation number. So I can represent the first step as the oxidation. The oxidation half reaction, and the second step is the reduction half reaction, and together we can calculate the net of the 2 equations. So we cancel out the 2 electrons here and here, and we write all the species that we have as reactants: copper, nitrate ions, and hydrogen ions, and then the copper ions, nitrogen dioxide, and the oxygen. Okay, the water molecule as a product. And now I'm representing a redox reaction. What is a redox reaction? A redox reaction is any reaction that involves any change in oxidation number. As you see, increased it will be oxidation half reaction, decreased it will be reduction half reaction. Okay, so here we have another example. Hydrogen as an element, oxidation number 0, chlorine 0. In hydrogen chloride, the hydrogen takes +1 oxidation number, the chlorine takes -1 oxidation number. So I determine, or I can judge, that it is a redox reaction. But sometimes not all reactions are redox. Let's see this example. Okay. Sulfur dioxide with water, it gives sulfuric acid. When you calculate the oxidation numbers for each, you will find that sulfur has +4 here, +4 here, oxygen -2 here, -2 here, oxygen +1 here, +1 here. So no change in oxidation state. in the oxidation numbers or the oxidation states for all the species that we have. So in this case, I consider it not redox reaction. And you will find in the lesson review of this section, question 3 asks about determine if the reaction is redox or not. So you will assign the oxidation number for each species, and you will compare it before and after the reaction. If there is a change, it will be redox. If there is no change, it will be not redox reaction or non-redox reaction. So you can apply the same here. Sodium here is positive 1, chlorine negative 1, chlorine here negative 1, silver positive 1, still positive 1, nitrogen positive 5, oxygen negative 2, negative 2. So also this one is not a redox reaction, and so on. Okay, so now we covered almost all the important points for this section. Okay, and we'll stop till here and continue inshallah with section 3. Okay, for chapter 19, section 3, the objectives, we will relate the chemical activity to oxidizing and reducing strength, and will explain the concept of disproportionation. We need to identify or to know the meaning of a reducing agent. A reducing agent is a substance that has the potential or the ability to cause another substance to be reduced. The substance that is reduced suffers a decrease in the oxidation state, right? So reduce in oxidation state means it gained the electrons. So it means that the reducing agent is the source of electrons, right? So the source of electrons, of course, is the element that is oxidized, losing electrons. Okay, so the oxidized element is the reducing agent. Okay, type. Apply the opposite for the oxidizing agent. The oxidizing agent is the substance that has the potential to cause another substance to be oxidized. Oxidized means it suffers an increase in the oxidation state or the oxidation number. It means it lost electrons. So it means that the oxidizing agent helps in gaining these electrons. So it is the one that gain electrons. Okay, and of course it is the one that is reduced. Okay, so the reduced substance is the oxidizing agent, and the oxidized substance is the reducing agent. So they oppose each other in action. Okay, and here more explanation or more details about this. Okay, that oxidation, it means positive direction in oxidation number or the oxidation state, increasing the oxidation number by losing electrons. Reduction, a negative direction, it means less oxidation state or the oxidation number decreased by gaining electrons. And you can apply the same for oxidizing agent and reducing agent based on our explanation. So the oxidation, okay, or the element that is oxidized, we consider it reducing agent, and the element that is reduced, we consider it the oxidizing agent, as we said. Then the strength of the oxidizing agents generally, and focus please with these two statements. The negative ion of a strong oxidizing agent is a weak reducing agent. Like what? Like negative fluorine ions. So negative fluorine ions are weak reducing agents because what's meant to again by the reducing agent? What does it mean? The reducing agent is a source of electrons. Do you think that fluoride ions here can be considered a source of electrons? No, that's why it's weak reducing agent. Okay? The opposite for the positive ions of a strong reducing agent. Okay? A strong reducing agent is considered a weak oxidizing agent. like lithium ions. Lithium ions now, lithium ions are considered the weak oxidizing agent. Again, what is the oxidizing agent? Is the one that gain electrons. Do you think now that lithium ions are able to gain electrons? No, that's why they are weak oxidizing agents. Okay, so generally negative ions are weak reducing agents, and positive ions are weak oxidizing agents, because this one now it is oxidized, and this one is already reduced. That's why it's weak in this action. Okay, then the last part of this section talks about a process called disproportionation. In a disproportionation, a substance can be reduced and oxidized at the same time. And the most common substance that undergo disproportionation is hydrogen peroxide. Hydrogen peroxide. Okay? So hydrogen peroxide has the oxidation number for oxygen. If you remember how to assign the oxidation state for the peroxide, it's always -1. Okay, after being decomposed into water and oxygen. So in water, the oxidation number is -2. By the way, not -1. Okay, so you see that it suffers decrease in the oxidation state. And when we compare the oxidation number in the peroxide to the oxidation number of oxygen in oxygen gas as an element, it will be from -1 to 0. It means that it suffers an increase in the atomic in the oxidation state. So here I have reduction, and here I have oxidation. So if a substance can be reduced and oxidized at the same time, or the two processes can be done within this material, so this process generally we call it disproportionation. Okay, so a process in which a substance acts as both oxidizing agent and reducing agent. So we consider hydrogen peroxide here a strong reducing agent, and also strong oxidizing agent, because it helps in reduction, and reducing agent because it helps in oxidation. Okay, so we're done now with the most of the important parts of chapter 19. Before we did section 1, and now section 3, and as we said, section 2 is cancelled. Thank you.